Dear colleagues, time for me to disturb you once again. Usually it's yearly, I'm saying, to these sessions. So a little about entrepreneurship. We are not used for these images in Denmark. Usually when we are watching these, and it's from Holland territory. So, but we actually gained a project on sand capping these muddy areas we have endless amount of in Danish estuaries, and the reason is to regain these functionally lost habitats because we have completely lost the anchoring capacity for seedlings in these areas, and the high frequency of resuspension in these muddy areas. It are also improving the light climate. So this activity, it is actually first started now, 22nd of May is this images from, where we aim to sand cap as a large scale test. One area, depths of 1.6 meters to 3 meters. We are capping 1 hectares. The LOI there, the organic matter, it is saying up to 11%, so it's very muddy. Other areas, it is 3 to 6% of LOI, and a little deeper, and then it's 2 hectares. And here we have up after quality control, checking if the sand it is really capping or the mud we have below, and we were asking for some 10 centimeters of capping of cap, and so these entrepreneurs, they are really matching up to this. It's impressive how good they are for the action. A little about Odense. Laura, she actually provided us with the information that covers very nicely also Danish waters, wasting disease, eutrophication, endless amount of that. And then moving into this Odense Fjord, where we have our playground. 62 square kilometers, average depth of 2.2 meters. Eelgrass covers is back to almost nothing. We have them up there as tiny spots. Tidal excursion, it's an issue up here. We are micro-tidal, only 30 centimeters. Residence times, it is then high, so 3 to 4 weeks in the inner part in here, and 1 to 2 weeks in the outer part. So it means actually that saying even we have these very frequent resuspensions, then the mud resuspended, it managed to settle before saying it is washed out. The present stressors we have on this recovery, it's the same as many of you have seen, lacking sediment anchoring capacity, and it means actually that these areas, they functionally, they are lost habitats for recovery. High frequency of resuspension improves the benthic light intensity. Ballistic impact from drifting macroalgae, saying we have a huge loss of the seedlings that manage to appear. They are all lost in the same growth season. And then we have the logworm bioturbation that is uprooting the seedlings that manage and are burying the seed banks. So. A little suite of publication. If anybody have problems by sleeping, then I'm able to provide these. So just attend me. Harbour authorities, and now a little of the background of this. Our harbour authorities, they stated these 8-10 years ago, saying the sand mobility along the Danish coastline, it have really increased after the seagrass patches they was destroyed. The navigation channels into all our cities that is placed in the inner part of these estuaries, it has to be restored much more frequently. And the sand now, it is actually dumped or sailed out to the remote official dumping sites. And then the question for us, it was to say, why not use this nice material as a marine measure? So we are recreating the quality bed in these areas. So And the sand capping, it is actually in our mind also providing a service, saying we are improving the anchoring capacity for eelgrass, we are improving the benthic light, and by reducing especially the resuspension strength, but also the frequency, and then support an increase in biodiversity and providing more stable ecosystems. And additional, we have an extra P absorption capacity that actually also matters in our waters. This is Troels, one of my PhD students, doing a very nice presentation tomorrow afternoon. It is in the mud, and he is diving, so he almost don't have any mass. And what you can see it is that he, without any problems, can put down all his arm into this mud area. So it's without consistency. We are talking about 90% of water content, and then this 8-10% of organic matter. And it's not a record. We have up to 20% of organic matter in some locations. So it's what we call fluid mud. If we recall, some of you maybe, this graph I showed a bunch of years ago, now we have a little extra information on it, is that if we are looking into the uprooting thresholds for seedlings, and saying in relation to both the sediment water content, and that is strictly related, of course, to the organic matter, then what we can see it is that in these muddy areas, then we have very low thresholds. It's daily, saying it's daily hydrodynamics we have where they get uprooted. Then we have the other end of it. It is in these very sandy area. Here we actually also have issues, and it's because the sand mobility, it is actually very high in these areas, especially on the exposed coastlines we have here. You have a little map of our where we have tried to wrap up the organic content in these sediments, and everything except from the light yellowish, it is actually where we have anchoring issues and problems. Then the story here I'm presenting, it is about how did we actually support data-wise on the sets of parameters. We were doing that in the lab. So we have, of course, endlessly amount of data where we in the lab have tried to look into saying sand capping, compaction of these cores, what is going on. We have, I have to go back. We have working with flumes where we have actually tried stepwise to increase the bed near current velocity and have it on mud bottoms, and then where we have sand capped, and then it's the same velocity we have here, 40 centimeters per second, and we can see the huge difference we have in the light climate. This is vertical profiles of when we are sand capping, how it is performing. We have this 10 centimeter of sand cap on top and looking on the water content, and what you can see it is that the signal is very clearly from sandy sediments we have over in the top. Then we have a mixing zone where the mud and sand are mixing up in 2 centimeters, and then we have the signals from very clearly from the muddy areas where we have this high water content. The same we see, of course, on the LOI. So it's a nice indication that actually the sand it is staying up in the upper zone, and it is not moving downwards. I'll not go through this table. I don't have time for it, but please grab me. But what we can see if we are looking on some of the parameters and other I have serviced you, you will see these graphs in a while. It is if we are looking into the median grain size distribution and then are looking into that, then you can see how it is performing, especially in the mud, and it is the sand fraction that is identical, and here we have the mud where we really are losing, so it becomes two very fine particles, very easy to erode. Then stating that then we have in the flumes, then we have tested it, this erosion. Stepwise we are increasing the current velocity, bed near current velocity, and then what we can see it is that saying we have a threshold already down in 10 centimeters, while when we have the saying when we have capped it with sand, then we are up to 40 centimeters before we start having erosion. The amount of erosion here measured as a concentration of suspended solids, it is, we are up in more than 600 milligrams per liter when we are in the muddy area. It's of course because it is in a flume, so we don't have so much water column, but we are down in 45 milligrams when we have sand. Wrapping that up also on graphs, then we end up having a huge difference when we are looking into erosion rates of this mud, saying from over this, saying with respect to the variations in these experiments we have performed with respect to the LOI content in the sediments. Here you have the graphs, again showing saying the impact we have, the graph impact of this seed on the seedlings with respect to uprooting. You can see that it is on the system level, then we have very nice signals between the LOI content and the water content. It's nice doing these physical experiments. It's the only chance to have very good statistics actually. I can recommend that. Sediment, when we are saying the flume experiment was providing us with a LOI versus the thresholds for erosion. And then of course wrapping it up with respect to water content and the wet bulk density. Here we are looking into vertical profiles with respect to our mud and when we have sand cap, and what you can see it is that even down in saying even the very low current velocities, then we are actually saying the light attenuation is really fading and decreasing compared to when we have the sandy areas. So it is wrapped up here, so you can see it's where we have options for recovery of eelgrass when we are in muddy areas. When we have sand caps, then we have a much wider window. So I have to move into saying the coming activities, as you were watching then, saying we have just initiated. So what we will end up with it is that we will end up having bare mud areas we are testing. We will transplant on these bare mud areas. We will have bare sandy areas, and we will perform transplanting of Zostera marina on this sand. And then we will follow the sand cap layer with respect to basic parameters. We will follow the growth and losses of these transplanted shoots. We will follow the succession of flora and fauna, nutrient fluxes, nutrient turnovers, of course inclusive the oxygen. Locations will be instrumented with cameras and loggers where we are performing all the general suite of parameters. So sorry for the disturbance.
Thank you, Morgens. I think there's time for one or two short questions.
Thank you for this interesting illustration of possible reuse of dredging material.
Yeah.
Very interesting. And I'm very curious to find out how it actually works in the field. I was wondering, those materials, if you put them in the field, you also have wave action steering up the bed. And if I understood correctly, your flume tests only had flow.
Yeah.
So, yeah, from an engineering perspective, I'm a bit worried that in the field, the mud actually comes through and the sun goes down.
You're not the only one being very worried about that. People into physics saying and sedimentology, they think I'm a little weird. But I think I actually can explain it to you. The friction among the sand particles are supporting the gravity. So it stays actually up there whenever we are pushing in the lab. And I promise you, we have been really beating up this sand cap layer in our flumes and labs. So meaning we are talking about small hurricanes, and it stays up there. Yeah, it's why we need the 10 centimeter and not the 2 centimeters. Yeah. So the ripples, when we are pushing high, then the ripples come down to, and we are really pushing, then it's 5 centimeters of ripples, so we still have a nice buffer.
Well, thank you.